mean life or average life. Mean life or average life, we call it as. Coming to this topic, generally what we know is the radioactive is a radioactivity when we observe it is random because we just can't predict which of the atoms in a given sample will be decay first. Suppose it's a given sample, so many nuclei are there here. Which will decay first, which will decay last, we don't know. So yeah, the radioactive process is we can say it is a randomly they will decay. Some nuclei decay in first zero, that is in 1 second, and some nuclei in 2 seconds. Like that, some nuclei they may decay till infinity time. So randomly they are decaying. We don't have one process in this one. So for that purpose, in this decay process, some of the atoms of given sample may have very short lifespan, and some may have the infinity, very large span of time, for decay purpose. So now, to determine the ability of nucleus to decay, it would be useful to calculate by average. So the average life is defined. How to define this mean life or average life? Means we have to say it as the total life. The total lifetime of all the nuclei divided by the total number of nuclei divided by the total number of original nuclei. Like that we can define here. So actually, what is the problem is that we are saying that nuclei are decaying, but which nuclei will decay in what time we can't predict. Some will decay at there is lost very within a short span, and some will take very large span. Because of the disturbance, we are going to calculate now what is average or mean life. Let me denote this average or mean life with the symbol tau. The symbol tau indicates average or mean life. So now, according to this definition, I can write tau is equal to sigma means summation, lifespan, of individual nucleus, lifespan of individual nucleus, 2 divided by total number of original nuclei, like that we can give the formula. So here what is this one? Summation. Sigma indicates summation means summing up of all individual lifespans by total number of original nuclei. That is a formula for average. This tau is called as now mean life. Sigma is summation, lifespan of individual nucleus by total number of original nuclei. You have to be very clear what we are doing here. The problem what we occurred, the random nuclei. The mean life means because of random the nuclear decaying, we have taken this formula for calculating average value, that average or mean value, we have taken it as tau. Now, let us observe the important point. Let us take N naught. What is N naught, beta? N naught is nothing but the initial number of nuclei. Radioactive nuclei that are present, that is, we can write initial number of nuclei, or we can write radioactive nuclei that are present at T is equal to 0, in a radioactive sample, radioactive sample. You have to be very clear with each and every term what you are using here to analyze this topic better. So please be clear what is N naught. N naught means we can say initial number of nuclei also. Now what happened means the number of nuclei which decay between t and which decay between time t and t plus dt, time t and t plus dt. T is some time, suppose 3 seconds, and 3 seconds plus some 2 seconds or 1 second you take. That means the time difference is what now? That is dt. In the time difference of dt, how many nuclei are decaying? Number of nuclei which decay between time and t plus dt is dn. So dn is nothing but number of nuclei decay in a time interval of starting time, suppose t, starting time I am taking it as t, next time t plus dt. That means time interval is dt. In the time interval of dt, how many number of nuclei are decaying means dn number of nuclei are decaying, dn number of nuclei are decaying. So here what we can call now, that is nothing but the lifetime of these nuclei. The lifetime of these nuclei is how much? Lifetime of these nuclei is how much? The difference in time interval here. That means here time is t here, t plus delta t. So difference is nothing but time interval. What is the time interval? dt. So the lifetime of these nucleus is how much? dt. I hope you are clear now. So the total lifetime of this DN nucleus is. So now the lifetime of this nuclei means what we have to take here? From T to T plus delta T we have taken. So initially till T only, no beta. We must take it as not dt. Let us take it as T, because we life after dt small interval of time they decayed. So lifetime is we can take it as dt. So now the lifetime of this nuclei is t. If you take, then what should I write now? Therefore, the total lifetime of these dn nuclei is how much? tdn. This is the formula. So now we have to do integration. We have to apply the integration now. What is average life? Now we got this one as TDN for the nuclear decay in that particular interval of time. But we want from total, from initially 0 to infinity time. So that we can write now the next formula about tau. Tau is equal to integral from where to where we have to do? T equal to 0 to T equal to infinity, and TDN by what we can write? N naught. N naught is initial number of nuclei. So from this is the formula what we got for tau. We know that minus dn by dt is equal to n lambda. From here I can write dn is equal to what I can write? Minus n lambda dt I can write, as n value is equal to how much? N value what we know here is n value is equal to n naught into e power minus lambda t. So substituting this one, I can write dn is equal to minus, in the place of n naught e power minus lambda t into lambda into dt. Like that I can write the formula. So finally by substituting this one, I can write it as tau is equal to 0 to infinity are the limits. T lambda n naught into e power minus lambda t dt by n naught. This is my final formula. Now, if you simplify this, I am not deriving this integration. Actually, I have to apply the integration, UV integration method and everything. Directly, I am giving the value tau is equal to 1 by lambda. If you integrate this one, Finally, we'll get tau equal to 1 by lambda. This tau is called mean life, or we call it as half life, mean life or half life. So this tau we are calling it as mean life or half life. Tau is equal to what we got? 1 by lambda. Tau is 1 by lambda we got. That is about mean life. Reciprocal of what we can write, mean life is nothing but reciprocal of decay constant. So conclusion we can write mean life of radioactive sample, mean life of radioactive sample is equal to what? Equal to reciprocal of decay constant. Reciprocal of decay constant. So this formula we need for objectives. For objective purpose, we have to know what is this tau and how they are linked with the half-life also. We just now we derived tau equal to 1 by lambda. Tau is called as mean life we told. Like that, we also have one formula called T of is equal to 0.693 by lambda. And this T of is nothing but half-life. We call it as half-life. Already we derived in our last class about T of half-life formula as 0.693 by lambda. From these two formulae, I can write it as, so tau is equal to 1 by lambda, or I can also write it as T of by 0.693. So now we got the relation between tau 1 lambda, tau 1 T of 1 lambda in one line. T of is half life, lambda is decay constant, tau is mean life. So we got the formula for all these three things now. I hope you are clear with this idea. This is one important point for objective point of view doing problems. This is one important point. Let us see one more application here. One application they are telling that. So here, suppose actually what we know, n is equal to n naught into e power minus lambda t from radioactivity. Suppose they are telling that the time, instantaneous time is equal to tau. If t equal to tau, what will happen? If t equal to tau means n is equal to n naught into e power, what I am taking condition here, t equal to tau. So n naught into e power minus lambda tau. So lambda into tau is nothing but 1. How you know, sir? Because as we know that as tau is equal to 1 by lambda, lambda into tau is nothing but 1. So from here I can write n is equal to n naught into e power minus 1. N naught into e power minus 1. What is e power minus 1 value, sir? E power minus 1 value is 0.37. So from this information I can also write n is equal to 0.37 times the n naught if that instant time we have taken as tau. So for a time of that is for a time of mean life, then how many number of nuclei remaining? 0.37 of initial number of nuclei. In percentages, how to write? Multiply with both sides with 100. What will happen? It will get a percentage. So we can also write it as n is equal to now 37% of n naught. N is equal to 37% of n naught. Very, very important formula here. So let us see the conclusions here. Just now we got n is equal to 37% of n naught we got. Here from this what we can give the information, the time interval during which 63% of sample decays, 63% of sample decays or sample reduces to 37% of its original amount. So this is the information. The time interval during which 63% of decays, that is 63% decay. Here what is N? N is remaining. So 63% decayed means how much is left over? 37% of original amount is left. 37% of original amount is left. Like that we can give the information here. I hope you are clear till here, beta. So this is the one of the important information. And let us now check some graphs here. Some graphs here, how to handle the graphs. We'll check it out. Next. Here, we are drawing the graph for now. Activity R and time T. Activity R and time T. Carefully observe beta. R is taken on y-axis. Time is taken on x-axis. So here the maximum value is what we have R naught. Whenever we are drawing the graph, we used to write for R naught and T. Already we explained in our last class like this. Because R is equal to what we have? R is equal to R naught into e power minus lambda t. So from this graph, we can understand that R and T, how they are related means exponentially means will get minus exponential will get rectangular hyperbola shape like this. They are telling that this is the R naught is initial, it is decreasing from that. Decay here, decay, activity is decaying. So for activity to decay, it will become off. So activity to become off means we call it as off life. So here let us take here somewhere in this one point here, let us take one point. So this is the point. So here what we can write R naught by 2. R naught by 2 the time taken is called as off life. R naught by 2 the time taken is called as off life. For average life, for average life, for average life. For time, if you put in the place of t, so in the place of t is equal to, you substitute t equal to t of means it is nothing but r is equal to r naught by 2. If you substitute t is equal to tau, you will get it as r is equal to what will get? R naught by e, R naught by e. So mathematically we have these relations. So by substituting these things here, we will find that. So here R T is equal to R naught by 2 when we say the time is of life. And now your time is mean life. Tau indicates mean life, T of indicates off life. Like that, the relation between off life and mean life graphically we can represent in this way. Very important beta for objective point of view also. This type of graphs you have to know how to handle the situations. Next, now actually n is equal to, we know, n naught into e power minus lambda t. So this formula we can also write it as, we know that n by n naught is equal to, one more note point, e power minus lambda t, and e will come this side means log n by n naught base e. We know this one already, we derived in our last class. So log n base e minus log n naught base e is equal to minus lambda t. We know all this one, and base e to base 10 I want to convert. Base e to base 10 means I can write now 2.303. In before step only we'll convert it off, otherwise instead of here we'll convert here only. Before step is better. So log base e to base 10 means you have to multiply 2.303 log n by n naught. Base e now became base 10 minus lambda t. So I can also write this step as log n minus log n naught is equal to minus lambda t by 2.303. I hope you are clear what we did. Nothing. This exponent is n equal to n naught into e power minus lambda t I have taken. Exponential I have sent other side. It became log base e. After that, log base e to base 10, I converted by writing it as 2.303. I send other side and I'm shuffling the terms. See the next step here. So log n is equal to log n naught minus lambda t by 2.303. 2.303. So here, what should I write now? This formula I can also write it as log n is equal to minus lambda by 2.303 into t plus log n naught. Suppose I am taking log n on y-axis and time on x-axis, Now I can write the formula y equal to mx plus c. M, you know, m is nothing but slope. Slope is equal to minus of lambda by 2.303. The negative slope. And C is called y-intercept. Y-intercept. Y-intercept value is log n naught. From these two things, what should I write here? I got here slope formula and C is y-intercept formula. This formula only we have just shuffled the terms and we have written form of straight line. So on y-axis log n, on x-axis time. Let me the graph. Now I am drawing the graph here. Here on y-axis what I am taking here? Log n on y-axis, time on x-axis. So what we got here? Log n naught is the initial y-intercept. Y-intercept is log n naught. Y-intercept log n naught means here we have to touch the graph at y-axis. That point is called log n naught. Slope is negative. Negative slope means you have to draw down. So here in the formula, if you observe there, what we have? Log n naught, okay. What is log n? At any instant of time. At any instant of time, if you take at any instant of time t, then that is written as what? Log n at any instant of time t. But if you substitute n is equal to n by 2, suppose for time interval, what we are taking now? This n became n by 2. This n became n by 2. So n became n by 2 means, that means initially it was log n. Now it became log n by 2. So what will happen? The time interval between n to become n by 2 is called as half-life. That is called as half-life. Now as this interval is half-life, because n to n by 2 we call it as half-life, I can write this as t plus t of. Like that, we can draw the graph for taking log n on y-axis and t on x-axis. This is the graph drawn when we are taking log n. What we have taken by the log n is equal to minus lambda by 2.303 into t plus log n naught. This is the graph. Log n what I told? Y-axis. Time on x-axis. Y equal to mx plus c. I hope you are clear with this one. So here what is the half-life period? Half-life period means what should I write now? T is equal to what we have, lambda is equal to what we can write, m is equal to what is slope here? Slope is nothing but angle. This angle is theta. This angle I can take it as theta here, theta. So what is the slope? Slope means y-axis term by x-axis term. Slope we can write y-axis term by x-axis term. We'll see in the next page here. Otherwise, we'll continue here only. M is equal to what we wrote here. Slope is equal to minus lambda by 2.303. It is a negative slope. Minus tan theta. Negative slope minus tan theta. So here from this formula I can write now lambda is equal to 2.303 into tan theta. So from this formula, what I have to understand, lambda equal to 2.303 into tan theta. Half life is equal to, I know that 0.693, or I can write this on 0.693. Instead of that, I can also have half life formula as 2.303 log 2 base 10. 2.303 log 2 base 10. And here what we got, this is 2.303 log 2 base 10 by lambda. Lambda value, what we know, lambda is 2.303 tan theta. So now I can write it as T is equal to, observe carefully, log 2 1 by tan theta is cot theta. So my formula for half life, T is nothing but here half life. Half life formula I can take it as log 2 cot theta. Log 2 cot theta. I hope you are clear with this mean life and connected the theoretical graphs and everything. So this is a very important topic for NEET point of view and JEE mains point of view. So please pay attention towards this topic. I hope you are clear with this topic, beta. Thank you, everyone.